architect. So I work at Microsoft, and I'm part of an organization called the Microsoft Technology Center. The idea of these facilities essentially is to, basically have high-level strategy briefings or even technical deep dives on specific areas. So one of the things that I have been lately focusing on, and it's been a big part of um, my job lately, is that especially with COVID hitting everybody really hard and everybody forced to working from home, what can I do in order to allow my employees to work remotely, but more importantly, how do they work securely? And at the same time, any of the risks that typically come from working from home, how do I address those, right? So as more and more customers are moving towards the cloud from on-prem systems, cloud-based security controls, what are they? How can I apply them? How can I use them? And what more can I do in the cloud to improve my security posture? Right? That's essentially the focus of our session today, right? As you can see from the session title itself, identity is the new barrier in the cloud, right? So, and what I mean by that is that in the past, right, we'll typically have the firewall be the barrier. If you're past the firewall, you now have access to data and users, right? But in the cloud world, right, it's the identity of the user that is the barrier, right? So that's the focus of our session today. Just real quick, if you want to follow me on Twitter, I try to be somewhat active, but if you do, that's my Twitter handle. I've also posted my LinkedIn URL here, right? Happy to connect and share information. Real quick, actually. So Nandip, in fact, said that let's keep our Q&A in the end, but I actually would prefer if we make this session interactive. I have very few slides because the intent is not to bore everybody first thing in the morning with long PowerPoint sessions, but I'd like to keep the sessions interactive, right? Because this is such an important topic, and we'll be covering a lot of key concepts. I want to make sure that as we go over these things, if there are things that need further clarity, let's talk about it, let's discuss it, right? Let's ask questions and things like that. So definitely stay muted, but if you do have questions, feel free to post them in the chat window, come off mute and ask a question. I'll try my best to monitor the chat window as well, right? Teams also has this feature for raise your hand, so if you feel comfortable, just raise your hand and I'll try to look for that as well, and definitely give you a chance to ask a question. So definitely let's keep this interactive, okay? If that's great. So all right. Um, so real quick, I'm going to go ahead and turn on subtitles. So if you think about the traditional approach towards how do you protect systems, right? So when you look at the traditional on-prem based systems, right? As I'd mentioned earlier, it's the firewall that becomes the barrier, right? Everything is behind a firewall, right? So you put all your controls at the firewall, you define all your rules there of incoming traffic, outgoing traffic, which ports are allowed, which ports are blocked. In some situations, you'll have a reverse proxy that is there for extending internal systems to be accessible externally, right? So you have many different ways people try to manage and protect those systems and information, right? The thing with the old world, right? So if I was always a remote person, right? If I was a remote person that's trying to access information, access systems, access emails, the intent always was that I have to access them via VPN, right? Um, if you try to look at how VPN access essentially worked, it was basically saying I could be on a computer, meaning a laptop, desktop, even cell phone, right? Having some kind of VPN profile even on your cell phones in order to allow external access to internal systems, right? That was always the process. Now let's take that concept and take it one step further and say, while I have all this, now if I had, let's say, like a corporate executive that's traveling, right, and needs remote access to emails or remote access to Teams or remote access to an HR system, right, or just remote access to an internal SharePoint site, we are not going to be requiring them to access things via VPN because it's cumbersome, it's complicated especially on cell phones. There could be an issue with speed and performance of how quickly my VPN tunnels are able to provide information. So what ends up happening more often than not, right? In those situations, you create an exception rule in your firewall, right? You say, all right, I for the most part everything's protected, but I will poke this little hole in my firewall and allow just one user, one set of users, to access information directly. This is not me making this up. This is literally what people do sometimes, right? You'll always have some exception in your firewall rules that allow traffic, right, to enable a certain business use case. The problem of taking that approach, though, is that if you create one hole in the firewall, it's not just for the corporate executive anymore, right? That same backdoor ends up getting used by, now in this case, a malicious attacker as well, right? So a hole in a firewall, excuse me, can very easily be manipulated by anybody else at that point, right? Anybody else that has malicious intent now has a means to get inside the system. Now, if you think about how that typically happens, right? The most common ways of doing that is, if you think about how someone tries to get in, right, is to look at, let me just do some basic password spray attacks, right, to see if I can do some guessing of passwords and see if that gives me some way to get inside a privileged system, right? That's usually how things start. The next thing they do is they'll look at the most common ports, like 3389 for RDP, port 25 for SQL, right? The intent with these ports being that these are the most commonly used ports, right? And especially in systems where they've not gone through the appropriate server hardening processes, that's my easiest way in to get inside a system, right? And most often, if you think about it, in fact, I'm sure you've seen it in your own jobs, right? When you go look at different organizations, they may still have things behind firewall, but the RDB ports are still set to 3389. SQL ports are still set to 1433, as an example, right? And so those ports, because they're default ports, it means that someone can make an educated guess that I can start from here, right? And so if you don't change those ports, there's my intake into your system, right? So in that scenario, once you start doing password spray, then it's very easy to do port scans. And the ultimate intent, right, for any malicious attacker is to start from the easiest point, right? So poking a hole in the firewall, starting from the easiest point, and then saying, how can I work my way to lateral movement and eventually find a privileged account, like a domain admin's account or a sysadmin's account. But with the intent being, if I can get to their account, I now have unfettered access to all the systems, right? So now I'm not saying that on-prem systems are inherently less secure. I'm not saying that. I'm not saying that, you know, cloud is better than on-prem. It's not any of those things. The idea is that the traditional approach of that walled garden, that firewall-based protection, right, for all systems, is not the best answer going forward, especially when everything's in the cloud now, or at least some things are, and more people are accessing systems remotely, right? It's no longer just about how do I keep things inside my firewall anymore. You have to think about this differently. As part of thinking about it differently, right, the industry standard at this point seems to be, let's look at it from a zero trust reference architecture perspective. Now, a quick raise of hand in Teams. How many of you are familiar with the zero trust reference architecture in general, right? Of what the principles are of zero trust? Can I get a quick raise of Teams raised hands, or just a note in the chat window, if you don't mind? One. Cool. Okay. All right, just one. Okay. We'll be going through those zero trust principles from a Microsoft perspective, right? But the one thing I will tell you right now is when it comes to zero trust, right? Think of it this way. Now, how many of you are familiar with the least privileged access model, right? That's been around for a while, right? So making sure when you design permissions into systems, making sure you're giving the least level of access required for them to do their jobs. How many of you are familiar with that? Okay. All right. So no worries. So we'll go into what zero trust is and some of the different ways people do zero trust. I'm seeing two raised hands. That's great. Um, the goal with this zero trust approach, right? One of the things we talk about today is saying that how can Microsoft 365 help an organization start their zero trust journey. Okay. And the zero trust journey inherently means what? In my organization, I have people who access information. I have devices that require access to information, right? Whether it's corporate owned laptops and desktops, corporate owned cell phones, personal cell phones, personal laptops and desktops, right? B by OD is increasingly becoming more and more prevalent, right? Folks want to have the latest iPhone and they want to have the ability to access basically everything from emails to Teams to OneDrive, SharePoint, Power Apps, Power BI, right? If you are using HR systems, right? Being able to have a native app from that SaaS offering and access HR information natively on iPhones and iPads. It's not unrealistic now to expect your end users to be able to have access to organizational data from their personal devices, right? With work from home, it's increasingly becoming even more and more of a must-have almost requirement. So thinking about it in the context of you have people accessing information, you have devices accessing information, and then you have the workloads themselves that need to be protected also, right? The intent of zero trust is essentially to say, I have these three different aspects: devices, people, and workloads. How can I take the data from those different services? And by data, I mean the audit logs, the usage logs, the authentication logs, right, that M365 generates when these systems are being used. How can I then apply a level of intelligence on that data to essentially generate some actionable insights? Perfect example. In fact, this happened to me. So about 2 years ago, so I live in the US. I live in a place called St. Louis, which is about 5 hours from Chicago. And I was traveling to India with at the time, my 5-year-old son. It was just him and me. And I was wrapping up my own SharePoint Saturday in St. Louis just the day before. So stress levels are very high. I'm the next morning catching a flight heading to India, heading to Bombay, actually. I'm from Bombay. Um, and in the process, I packed everything. I forgot my work laptop here in St. Louis. I'm like, oof. I have meetings that I was going to attend, and when I come back from India, I have a customer engagement the next day, so I had to prepare for it. So I was really hoping to get my laptop. Well, I didn't have it with me. So the minute I land in India, I asked my sister, "Hey, can I borrow your laptop? I need to set it up for my access, that kind of stuff." She said, "Sure, no problem." Well, the thing is, in that situation, when I tried to set up her laptop for access to my data, my teams and my SharePoint sites that I was going to use, well, I basically got 3 or 4 separate prompts. One to register the device inside of Intune, her laptop, multiple MFA prompts, and there were a couple of SharePoint sites that were classified as highly confidential that I could not even get to from her laptop because her laptop was not domain joined, obviously, right? I wasn't going to domain join her laptop to the Microsoft network. So the intent was that I needed access to information, but there were several different checks at different points that allowed me to do different things, but not everything from that laptop, right? While I was completely remote, right? I'm in India. And I'll tell you, there's a slide where I'll go into more detail of that scenario exactly and what the different checks were. But the point of this is this. When you think about zero trust, it's about the fact that all devices, right? If you look at this slide especially, all types of devices, all types of scenarios, they can be anywhere. They can be inside the network, they can be outside the network, they can be cell phones, they can be smartwatches, they can be IoT devices, they can be physical desktops, they can be other clouds. I may have data sitting in AWS, for example, that has some interactions with the Microsoft cloud. There can be any number of scenarios where any number of systems and or devices can access or may need to access our information. So at that point, if we still go take the approach of everything being behind a firewall, this becomes a very difficult system to implement because, for one, all traffic is being routed through your VPN tunnel at that point, which means what? Your VPN tunnels are going to they end up being the bottleneck. Every traffic comes through the single pipe, right? And it's going to get throttled because most tunnels aren't built for that level of scale, right? They never are because it's always meant to be, hey, primarily I'm in the office. So I'm hardwired for access to my internal network. VPN only gets used when I'm remote, right? But now with everything being open, everything being on on a wrist, and I need to access the information, you can't expect VPN anymore, right? So the intent of zero trust, right? The next aspect of zero trust is to essentially say, assume every resource is on the open internet. What that means is assume that any device and any service that you want to access can be accessible remotely, directly via the internet, does not require VPN tunnel, right? And I'm not saying that just keep it open, oh, everybody has keys to the kingdom. That's not what I'm saying. But when you make it accessible via the internet, what you're now doing is saying, I'm not just looking at your IP address as the only way to approve or block access. Because in a VPN scenario, that's what you're doing. You're saying if you're coming from a trusted IP, it's all good, right? But what we're saying with zero trust is IP address is no longer the only vector that I'm looking at. I'm looking at identity. What identity is being used to access this information? Second, what device type is being used? Is this a personal device? Is this a domain joined device? And further, what type of activity is taking place on the device? Location. The fact that my Microsoft account was always used from the United States. I've never used that account outside the country. Well, when I traveled to India, that was the first time I'm using my Microsoft account outside the United States, right? So that in itself should raise a flag in a system somewhere, right? So taking that location vector to further drive the decision-making process of should I or should I not allow this person to have access to this information. Number four, workload. I can now start taking a more calculated decision on should I or should I not allow access based on the type of service. Meaning, Teams, you know what? Okay, everybody can get to it, right? And I'll keep that to be a less restrictive workload. But if I were to be saying, hey, the HR application, right, and I'm using either Workday or Success Factors, right? Those applications have sensitive employee data. So no, I'm going to make that more restrictive, right? Even though it's on the open internet, I'm going to have more restrictive rules to keep that system safe because of the quality and the kind of data that's in it, right? So you can now have a workload-based decision-making process of how you create and manage access for those services. And then finally, this idea of saying, based on all the parameters of identity, device activity, location, and workload, what if I can have some kind of a scoring process on a real-time basis to create and measure the risk of the session and the user? And based on the risk scoring that happens in a real-time basis, I can then have the system decide, should I or should I not allow you to have access to the service? That in itself is how you can start saying it's okay for my services to be on the open internet, meaning without a firewall, because at this point, my validation for access or no access is not just based on IP range or IP source, it's based on all these other variables: identity, the device, the activity on the device, location, and workload. So the final point, and this is the biggest point about zero trust. So if you ever think about zero trust and think about what is the one thing I should always remember about it. It's this cliched tagline: never trust, always verify. Now, just think about this for a second as to what this actually means. So, going back to my point from earlier, which is it's okay for your services to be on the open internet and not behind a firewall, right? If you think about how things were done before, right, where you had to be on the internal network in order to access something. Well, in that situation, there was an implicit trust that was always happening, which is as long as I'm coming from a domain joined device and I'm coming from a trusted IP, that's it. I'm good. I have that it is a point in time snapshot that is taken of um, my session information at the time, right? Of hey, I'm coming from a trusted device and I'm coming from a trusted IP, which means I'm safe, right? This is a safe session, and I have unfettered access to all the systems that I typically work with. The implicit assumption there is, well, okay, I checked it once, I don't need to check it again, right? In the cloud world, that's a terrible idea. It's a terrible idea because at any given point, things can change. I can walk away from my desk. My device can get compromised. I can get malware installed on my machine, right? There's no real time um, incident response, right? If you think about the traditional, EDR solutions, right? Endpoint detection and remediation solutions, right? Those solutions thrive on the fact that they can take a real-time assessment of the devices, and if the devices are compromised, there's real-time detection and remediation of that happening, right? That's the EDR part of it. But then it's basically saying, how can I take that EDR component and feed that back to my rules of access and say, hey, something changed on this device. This device cannot continue to have access to the services. But in the traditional world, there's no way to enforce that because your firewall rules are pretty explicit. If I'm coming from a trusted device and a trusted IP range, I have access. But what zero trust is saying is, at no point am I assuming implicit trust. Hence, never trust. At every given point, always verify, right? So that's the core principle ultimately of zero trust. Now let's talk about how we actually do that, right? At least in the Microsoft world. So, so if you think about on the left, what you see are the traditional things, right? We're doing the traditional, existing on-prem based systems. And on the right is how we approach it in the zero trust world. So if you think about how we do it today, right, from a networking perspective, we try to increase the security posture by creating these segmented networks, right? I'll have my own separate VLANs as an example, and then my customer facing or public facing websites will be on a set of servers that are sitting in my DMZ, right? So at that point, they are there on the outer side of the firewall. Hence, they can surface all the websites that our customers use. And then you will have other internal only networks where you maybe host your servers that are the backend servers, the application servers, right? So you're already doing the segmentation today, right? What we are seeing in the cloud world is actually a logical micro segmentation. And I'm going to show you that how in just a minute. But it's not about segmented networks. It's micro segmentation on a service basis. Okay. Second thing, we on the left, we start thinking about things like how can I do packet tracing and logs, right? In terms of how do I understand what's really happening in my environment today, right? So you look at firewall logs, you look at network logs, trace logs. That's how you get information, right? But it's all passive, meaning it's already occurred and you're looking at that data, right? On the right, what you see, 6.5 trillion signals, correlated signals per day. What does that mean? On the left, all the data, like I said, is based on activity that's already occurred in your system. On the right, what we're saying is when you're in Microsoft 365, the threat correlation of, hey, I'm seeing a bunch of symptoms, right? Perfect example of malware. The symptom would be, I'm going to pick on Shailu. I see your name first in my list. So I'm going to say is Shailu is on an average, right? Can folks still hear me, by the way? Just want to make sure.
Yes, Ajay. Yeah, we can
Okay,
hear you.
perfect. Thank you. So like in case of Shailu as an example, right? You have I can start tracking some behavioral data, heuristics data, right? We call it UEBA, user and endpoint behavioral analytics. I can have UEBA data about Shailu's behavior. On a typical basis, Shailu deals with 50 files and has about 500 megs of down traffic and 50 megs of up traffic. But suddenly, my system is detecting that Shailu's account from Shailu's laptop is is editing hundreds of files, thousands of files, right, in a given minute even. And that is unusual behavior. That's anomalous behavior. So how can I take that type of a system alert to do the threat correlation to say this looks like a symptom of a ransomware attack, right? If you think about how ransomware attacks work, right, from a single device that's compromised or a user that's compromised, I'm now encrypting all the files in a file share, in a OneDrive, in a SharePoint site, things like that. But the fact that I can take massive file edits, which are now unusual for Shailu, as a symptom of a potential ransomware attack, that's where automated incident response can say, I'm going to lock down Shailu's access to files going forward to limit the damage. That's that proactive security approach that you get from having those 6.6.5 trillion correlated threat signals, right? Because Microsoft is making that assumption that this could be an indicator of threat, indicator of compromise, IOCs, based on what we have seen from all of our other customers who are also Microsoft 365, plus what Microsoft internally sees on a daily basis, right? We are constantly getting attacked every single day for our own internal systems. How can we take the learning and intelligence from that, plus the learning of our other customers and how they are being attacked, plus if you think about our Xbox networks, right? So the whole gaming network for Xbox is massive. And if you think about the kinds of attacks that happen on the Xbox network, they're ridiculous. It's crazy. And so what can we do from a learning perspective to take that knowledge and apply that to our enterprise customers? That's where that 6.5 trillion correlated threat signals come from, right? Versus in the traditional on-prem world, my intelligence is really coming from just my data and my logs, my firewall logs, right? Which is fine, but it's not the complete picture, right? So that's my little example there about how things can shift in the zero trust world in the cloud, right? I mentioned this point earlier, this next point about inferred trust versus explicit verification. Inferred trust on the left being if you come from a trusted device and you come from a trusted IP, I'm assuming trust and I'm not doing any more verifications. As long as a VPN connection is open, your VPN tunnel is active, and you're still coming from a domain joined PC, I have no reason to suspect that there is any malicious activity taking place. On the right, there are built-in controls in Azure AD and whole M365 stack, in fact, on constantly doing verification, right? And based on any of the metrics changing, I can apply automated controls. I'm going to show you how in just a second, but that's the idea. That's how you. That's how we are thinking about trust in general. This fourth point about reactive versus automated response, right? So if you think about looking at point number 2, right? This is an extension of that. My reactive response is reactive because it's based on logs that I'm seeing of something that's already occurred. When I say automated response, it's the same example I gave earlier about Shailu and your ransomware attack, right? When a ransomware attack takes place, looking at indicators of compromise, like in this case, anomalous behavior on Shailu's account, and having built-in intelligence to say that's anomalous for Shailu. So I'm going to go ahead and assume this is a potential ransomware attack and lock its account right away. That's an example of automated response, and that's just one of many examples. I'll give you another few examples here in just a minute, but that's the kind of automated response, because at the end of the day, let's face it, there's no there's no system that's going to say here's 100% foolproof solution of you know, preventing attacks or preventing breaches and preventing accounts being compromised. There's no system that's going to ever promise that, and if they are, they're lying. So the question becomes, it's not about reactive anymore, because if you're being in a reactive state, you're losing time, precious time, and then in a precious time, data is already encrypted. So now you're either relying on backups or you have to pay the ransom to get the decryption keys on those files. So the question then becomes, with an automated response, am I buying myself some time to limit the damage? Because with automated response, you're not relying on a human to take some action based on data in the logs. You're essentially saying, let the system use its intelligence, find indicators of compromise, and then take the appropriate response. That's that automated response aspect that's built into Microsoft 365. And then this last piece, right, that kind of brings it all together, which is the traditional firewall-based solution that we think about, right, where everything comes behind the firewall. It's the traditional, here's the walled garden that I'm building around my data, right? And I'm poking holes at each point if I need to, enable some special use case. In the modern world, we're saying it's an expectation that anybody can get to their data from anywhere as long as they have proved continuously they are who they are and they are doing safe activities on an ongoing basis. So the intent becomes, you're no longer saying, oh, you only can access information from corporate approved devices. No, let's say BYOD is an option. If I can put all the right controls in place to ensure you can still do all you have to do from your personal device. Like even at Microsoft, I have an iPhone, right? But it's a personal iPhone, but it's MDM enrolled instead of Intune, which means Microsoft has put all their robust controls and policies on my device, and I'm okay with that because I trust the fact that they don't have access to my personal information. But at the same time, I get the benefit of doing everything I need to from my phone now as well, right? So that expectation of having that mobility is something that you just get, or you at least have the ability to do with a more cloud-based, zero trust-based security architecture. All right. Let's see here. All right. So just a separate slide just on the Azure AD marketing side of things around where we are seeing major adoption for Azure AD, right? Like, and this is even like a year old piece of data about 27 million users who are already on this zero trust journey. I think it's significantly higher than that, but I know this is from last year, I think. So I just have this here. Now this next slide, this is the money slide. This is the magic sauce where you can see how how everything I just talked about so far actually gets implemented. So in fact, I'll start with this. So what I'm going to do, let me get my laser pointer here so I can start pointing things. So what you see on the left are essentially all the different variables that are now being considered in a true zero trust based security architecture. The first variable is in fact the identity. How is this person essentially authenticating before they access the system? Are they coming from Azure AD? If it's pure, all my systems, including on-prem and cloud services, are all leveraging a single shared identity provider, Azure AD. Well, fine, great. That can be one way of looking at authentication, but that's not always the case. you're going to have a flavor of Azure AD and some form of AD authentication. At which point you're looking at ADFS, right? So you'll probably have ADFS that's doing federation between AD and Azure AD, right? You probably also, right, and we know Microsoft 365 allows this quite well, which is allowing for external sharing, right, in Teams and SharePoint, OneDrive. And so when you think about those external sharing situations with personal accounts, they are personal live.com accounts, outlook.com accounts, hotmail.com accounts. So we call them MSA, right, Microsoft accounts. And so it's entirely possible that the users who are authenticating are using their personal Microsoft accounts to authenticate against enterprise data, right? That's entirely possible. And then the last scenario being, and this was added, I think, in the last year and a half or so, where you could do business to business B2B federation with Google ID. So the situation being you are an organization that's in M365, but you're working with a partner or a vendor that comes from the Google Cloud Platform, right? So they're on GCP, not Azure. And GCP has their own enterprise identity store called Google IDs, right? So they come from Google IDs, even though you're M365 and Azure AD. How can you start doing federation so that they can access your information via their Google ID so that you're not actually creating accounts for them and managing it for them, right? So Google ID can also be an option. So the point here being your authentication uh, um, ecosystem could be a combination of all four types of identities, essentially, right? Today, especially. And there's a whole other B2C that we won't get into today. That's a whole different conversation. But you can say, hey, someone can log in with their Facebook account or LinkedIn account, any kind of external SAML-based authentication or identity provider. That's a different conversation around B2C. We'll probably maybe have on a different day. But at this point, these are the four core identity types. The second variable, they could be coming from Android, they could be coming from iOS, they could be coming from Mac OS, they could be coming from Windows 10. And lastly, they could be coming from a device that's got any of those OS platforms plus our Defender service, right? So if you're familiar with Defender for Endpoint, it used to be called Defender ATP. Now we renamed this a Defender for Endpoint, and we have those for Mac, for PC, iOS, Android, Linux even, right? So the intent could be it's just those device platforms or those device platforms plus the Defender service. And that can play a part. I'm going to show you why in just a second. But it could be any of those devices because, again, in today's world, anybody can access or would want to access any of my services from any device platform. It's their choice. The third variable in this mix is the location. And by location, I mean IP range. So if you think about how things are set up today, even in the Azure AD world, I see a lot of customers basically saying, let me do conditional access rules, pretty basic conditional access rules to say, if any of my requests are coming from inside the network, and when they say inside the network, it really means physically inside the network or logically via a VPN, right? That's what they would call trusted IPs. So anything that's coming from a trusted IP range is considered corporate network, right? And they would basically say, if you're coming from a trusted IP, no MFA prompts. If you're outside the trusted IP range, I'm going to prompt you for MFA. Tell me if that's not true in some of your cases, but that's what I have seen with most of my customers. Is that's how they've set up their MFA? Which again, no faulting that, but you're only doing half, in my opinion. There's more you could do with this, right? From a zero trust perspective. But that's where they start. So what Azure AD also allows you to do is just above corporate network, right? You see this thing called geolocation. And what geolocation essentially does is, for example, I'm working from home right now, right? And I'm not VPN'd in. Right now, I'm not VPN'd in. So Microsoft example does split tunneling, right? So there are certain things that require VPN connection. Other things don't. Most other things don't. And so what we do is instead of doing forced tunneling where all traffic gets routed through the tunnel, we say certain things they can go straight to the internet, and other things require VPN. So we have an always on VPN service that runs but never gets used unless the specific DNS request requires that VPN tunnel, right? So we do split tunneling, and a lot of customers are moving in that direction now just to reduce the bandwidth requirements on their existing VPN tunnels. Right now, everything's going through VPN tunnels, so things get throttled. You get performance issues, Teams calls. It's impossible to do video calls, and sometimes when you're doing video, screen sharing stops working. Things like that, right? So you start seeing all kinds of issues because of that. So, anyways, with what geolocation does is to say that um, when I'm working from home, I have my home ISP that is being used to generate my IP range, my IP address. If within Azure AD, I have now got a sample data of 30 days of safe activity from this device, from my home ISP's IP address, then Azure AD basically generates a user centric list of safe IPs saying that yes, my security department has configured trusted IPs for internal network, but Azure AD will say this home IP address is a safe IP address for Ajay's identity, Ajay's Azure AD identity, right? So it starts maintaining a user-based or user personalized geolocation location of safe IPs. What that means is now going forward, when a new request comes from my device, from my IP, I'm considered low risk, even though I'm outside the network, right? And then now, if I were to say, all right, my internet is down, or I've lost power, and I'm heading maybe to the the nearest, coffee shop and using their public Wi-Fi to connect. Well, okay, new IP address, which means my risk just went high again because that Azure AD has no idea or no record of my identity being used to access information from this new IP address, right? So that whole concept of geolocation becomes very important because it's now got intelligence to say, hey, I've seen 6 months of safe behavior from Ajay's account, right, from this IP, right? It's safe to say this is a safe IP address, right? This is not a risky situation, right? So that's what geolocation means here. And then this last variable down here is what type of app is in fact being used to access information. Is this coming from a thick client? Is this coming from a thin client? Things like that. That's another aspect that can be considered now in terms of is it coming from a Tor browser, right, or is it coming from an Outlook client, things like that, right? So those aspects are considered in this last variable around browser apps versus client apps, right? That's the last variable. So the intent with this, right, it's essentially to say these could be the conditions that drive what happens next. So let's talk about what that next even means. Oops, sorry. All right. I'm just going to build this slide out and talk through what this is. So based on all of the things that are happening on the left, right, based on which identity gets used, which device platform I'm coming from, what IP range I'm coming from, and what app type I'm using, I can create policies, right? Azure AD conditional access policies that say if I'm coming from this IP range, don't prompt me for MFA or vice versa. So you have those policies. But now what's happening is there's a machine learning component that gets added to this. So if you think about what machine learning is doing here, if you remember from one of my slides from earlier, right, I had said there are about 6.5 trillion threat signals that are being correlated on a daily basis. Well, that whole combined threat intelligence, that's this 40 terabytes of data coming from over here. So what machine learning is saying is I have all that data I have data about your login behaviors, your devices, your IP addresses, your applications. I'm going to apply machine learning. I'm going to apply ML on this and start generating a risk score. There is a session risk score and a user risk score. Okay. And what this is doing is saying, just an example of what I was showing earlier about myself. I traveled to India and I'm accessing Microsoft data from my sister's laptop for the very first time. So think about what changed there for me from a UEBA perspective, user and endpoint behavioral analytics perspective. My Azure AD identity, not a problem. I did MFA. I still had my phone with me. So I had the Authenticator app on my phone. I MFA'd in, not a problem. So Azure AD, check, right? From a device perspective, yes, I came from a Windows 10 device, but at the same time, it was a brand new device, never used before. Microsoft's Intune service has no record of my sister's laptop. Obviously, makes sense. So that alone drove my risk to a medium, right? Then I came from a device that also does not have the Defender service on it. Risk goes higher. I'm coming from a brand new IP address. Not just that, I'm coming from a brand new country that I have never used for access before, right? Never gone out to the US with this IP ad with this identity. So first time seeing access from a brand new country for Ajay's identity. My risk score goes from medium to high in the red, right? Both for my user identity as well as my session itself, right? The risk scores red. That's the kind of stuff that machine learning is doing over here, is to take a combination of your policies that you define over here plus all the data coming from here on the left plus behavioral analytics about. I have no recollection or no record of Ajay's behavior in any of these scenarios. They're all brand new to him. So all of those will then automatically elevate my risk to be high. That's when your policies can be configured now to say if my user risk is high, I can automatically set up an action here saying force password reset. So think about that for a second. User risk being high could be what? Okay, here I authenticated successfully with Azure AD. But now think about this for a brief minute. I last logged in with my Azure AD account. If you think about it, India, the flight from St. Louis, where I live, to India is about 28 hours with all the layovers and wait times in the airports and things like that. So realistically, right, assuming I didn't use Wi-Fi in the plane and did any work stuff, the last time Azure AD saw any authentication prompts for my account were 28 hours ago, back when I was in St. Louis. And then there's a 28-hour period of wait time when nothing is happening with my identity. And suddenly I'm logging in India with my Azure AD identity. So there's been a gap of 28 hours. Azure AD has enough intelligence to say, okay, I can still think that's a J. Now imagine this though. I land in India, right? And I'm trying to log in, but Azure AD has found a record of me logging in or someone logging in with my identity just 10 minutes ago from an IP address that was based in London or based in the US. Well, clearly, unless there's some weird network routing or VPN stuff happening here, there's no possible way that Ajay could have logged in from the US or from London and then 10 minutes later log in from an Indian IP address. So I'm going to assume the worst and say that this looks like a possible credential theft, right? The internal alert name for it is impossible travel. It's impossible for this to happen in the course of 10 minutes. 28 hours makes sense. 10 minutes does not make sense. So this is machine learning then saying that Ajay's identity could be potentially compromised. User risk goes high. Automated response, force password reset. Where does that happen? In the policy that you define here, right? This is my example of automated incident response. This looks like a impossible travel, a credential breach situation. So I'm going to assume the worst and force a password reset, which triggers MFA and all those other controls now, right? But that's a good way of saying, here's me applying more intelligence and saying, I'm not just going to assume IP address based protection. I'm here saying every single point, real time verification to say, based on behavioral information and other things, this does not look right. I am going to adjust the risk score. Think about another scenario where everything checks out. I'm using an Azure AD account with no credential theft happening. I'm using it from a corporate joined device, fully Azure AD joined or domain joined, right? So everything checks out there. Coming from an internal IP address, but I'm happening to use a Tor browser instead of using Edge or Chrome or Firefox or something like that. I'm using the Tor browser. Well, the Tor browser is intentionally getting used because someone wants to anonymize themselves. Well, okay, you want to use that, that's fine, but your session risk this time is going to go high. Session risk goes high, automated response, block access. Simple as that, right? Or in fact, in my example, right, when I was telling you earlier, I was able to do everything after my multiple MFA prompts and things like that. But there were still some internal sensitive SharePoint sites that I couldn't get to because it said I got policies here that block me from accessing highly confidential data. Well, in that situation, that's limited access. I can access some information, but I can't access all information. Or in certain situations, if I'm accessing data from a browser, I have limited access again in the sense that anything that's marked as confidential, I can only open them in the browser. I can't open them in a thick client. I can't open them in Outlook or Word. I have to be in Outlook Web Access. I have to be in Word Online, things like that, right? At any given point, that's the zero trust implementation, which is at no point am I assuming anything. Each time a new request comes in for even in an active existing session to access some information, all those checks are happening on a real time basis. The combination of the policies you create, the machine learning, that's happening in the back end, and the real time evaluation engine that's generating the scores of your session risk and user risk, and those two scores alone drive all these policies. The big point here becomes you're no longer making that binary decision of allow or block, MFA or no MFA, right? It's basically saying it's an adaptive MFA, it's an adaptive conditional access, or what we call risk-based conditional access, right? So ultimately, that's the whole idea here, right? And the last point I'll do, and I'm going to wrap it up here now, but the last point with this is that the intent of this becomes, right, that going forward, when you start doing this, you will now have the ability to have Azure AD be the central identity provider and the authentication provider for not just cloud-based systems, so not just Microsoft Cloud, but like third-party cloud, Oracle, Salesforce, Workday. Uh, there's a big list. In fact, we support natively like about 3,500 different third-party applications via Azure AD for native authentication, like an IDP even. But you can say that I can essentially extend that to on-prem as well, which means all these controls around zero trust can now be extended from not just cloud apps, but also to your on-prem apps, right? At which point I now have complete visibility and advanced zero trust controls for all systems inside my organization. Is that just going to magically happen overnight? No, it's a long journey. It's a painful journey, expensive journey. But as you look at how CISOs get measured, right, in different companies, it's not based on whether they can prevent a breach, because the reality is no one can actually prevent a breach, right, these days. Their measurement happens based on their readiness for if a breach does happen, what next? Are you prepared to deal and come out of it and limit the damage, prevent the damage? Do you have all the controls in place, right? Have you made it harder for someone to get to everything, or have we just made it super easy that everybody can get to everything, right? That's how they get measured. And so going on the path of zero trust, it's a long journey. I don't think it even ends, to be honest, but it goes a long way in, again, protecting data, protecting users, and things like that. So there's more to this, but we only have an hour today. So this is a piece I wanted to make sure everybody kind of understood, right? This whole risk-based conditional access and how that feeds into your zero trust reference architecture. So at this point, I'll pause and see if there are any questions.